Good morning, ladies and gentlemen. Welcome to another stats lesson. This lesson is about assumptions and conditions. The first assumption that we want to talk about is the independence assumption. Basically, we want to know if our data truly falls under the independence category, or if it was independent data is another way to put it. Well, when is it safe to assume that it was independent? Let's talk about that just a little bit more. If there's no reason for the independence assumption to fail, that's a pretty good indication that, it really was independent data. But if you can think about a case where it might fail, then that's something that you need to know about. So basically, you need to know what the situation is. Let's say I'm asking my class what their favorite color is. If nobody's looking around, then it's no big deal. They're going to answer truthfully for themselves. But what if their friends are looking around? Oh, wait a minute. Does your friend influence you? Of course they do. They may get you to say the same exact answer they want to so you fit in, or perhaps they can even trick you into saying the answer that you didn't want to say just because you want to disagree with them that day and they know that about you. That's a pretty good situation that you know it's not really independent data. Oh, by the way, just because you happen to have a nice set of data, you can't determine if it's really independent or not. You need to know something else that's going on, like the background to how it was taken, etc. Also, if the data happens to satisfy the randomization condition, well, that's a good clue that it's independent. Data sampled at random, or data generated properly from a randomized experiment. Good case, yep, it's going to be independent. And oh, by the way, it can't break what's known as the 10% condition. The 10% condition basically says that if you sample more than 10% of your population, something's going on that you probably don't want to have to deal with. And oh, by the way, this really only happens when you have a really small population. The next assumption and condition that we want to deal with is actually the sample size assumption. We need to know if the sample size is large enough to make the sample proportions approximately normal. To help us with this, there's a success or a failure condition. Part of this says that if there's at least 10 successes, you're in good shape. A success is any time that an outcome that we're looking for actually happens. Just because we say that we won or we lost or something of that nature, it really depends on what outcome we're looking for in this case. And by definition, if it's not a success, it's automatically a failure. We must also expect at least 10 failures for this condition. A failure is when the outcome we're looking for does not happen. If it is not a failure, it absolutely must be a success. So you really only have two choices. Let's clarify that just a little bit with an example. A poll was conducted asking 101 random sampled people for their favorite color. The top 4 responses were as follows. Red got 33%, blue 25%, green 10%, and yellow 5%. Notice that there's probably not 100% there, is there? Well, they only gave us the top 4 in this case. From the data above, if we choose red as the response we are looking for, or by definition our success, is the success or failure condition met? And just to add on to the example, also from the data above, if we happen to choose yellow instead of red as the response that we're actually looking at, or our success, is the success-failure condition actually met? Well, let's try to answer those questions. For part A, if n is the number of people that we actually sampled, 101 in this case, and p hat is the percentage that answered for the successful way, or red, 33%, then when you take 101 and you multiply it by 33%, you get about 33, and of course that's greater than the 10. Likewise, if you take the number of people that we sampled and anything that was not red, represented here by Q hat, that's 101 for the number of people we sampled, 67 for the percentage that didn't answer red, and when you multiply that together, it's pretty close to about 68, and once again, that's more than 10. Since both calculations are above the 10 for the success-failure condition, it's met, so we're in good shape. For part B's example, when we're talking about whether it's yellow or not, in this case, the number sampled is still 101, but now p hat is only 5%, because only 5% said yellow. 5% times 101 is about 5, and that's less than 10. And then in Q hat, well, 101 again, same sample. 95% now didn't say yellow, so that gives us about 96. That's well above 10. But because one of the calculations is less than 10, the success failure condition really isn't met here, so that's not a good case. So basically we've covered two different types of assumptions, one about the size of the sample and one about the independence. Have a great day, and I look forward to seeing you in the next stats lesson.